Hi, my name is Arjun and welcome to Energize, the tech revolution. Today we have a very special guest amongst us. Kyle FALOON has worked in and around industrial operations for the past 14 years. During this time, he's helped build and design machines that work in these facilities or help to maintain and troubleshoot these machines. He has also spent time building and starting up these multi-million dollar facilities or help to build programs and teams that are responsible for maintaining and optimizing day-to-day operations. This has taken him from remote northern oil and gas facilities to manufacturing warehouses and large facilities to power plants that keep the lights on or chemical facilities that make the fertilizer for the wheat in our bread. When he's not working, he's spending his time traveling in the mountains, having developed a passion from his youth and years spent guiding children in the backcountry. Welcome to the show, Kyle.
Thanks for having me. I'm excited. There's good list of questions today. So
Yes, absolutely. So, Kyle, before we get into your professional background, would love to hear more about your educational background because you have participated and pursued various educational programs, those being the machine learning certificate, the industrial product design, full stack design, and also being an apprentice in instrumentation and control tech. Would love to hear what inspired you to pursue so many programs and your experience in those.
yeah, so I can sort of say like I've always been drawn to this idea of problem solving or like the sort of the common through line in a lot of this is like all these sorts of tasks or jobs or education programs I've been part of is problem solving is sort of the fundamental element in them, right? And they all sort of drive to the question of a better understanding of what I'm trying to work on or engage with, right? So that that is that common theme, and then it sort of drives into like it's really fun to think creatively around how do you solve a problem, and then you can start to blend this sort of like physical and intellectual pursuit of, you like when I was an instrumentation tech, you'd physically go out in the field and wire something up or bend tubes or, troubleshoot how are you going to fit this thing that needs to have certain priorities in a confined space or in a situation. And then you also have to figure out how are you going to interpret the data from that into some sort of meaningful result as well. So you sort of get this interesting blend of, or my education's been an interesting blend of like physical problem solving and intellectual problem solving, which has definitely treated me well in my sort of current role.
Well, glad to hear that. I'm glad you got to get that well-rounded educational experience, Kyle. So now let's dive into your professional background and journey. So could you share what took you into, becoming a product leader in the industrial operations space? And for the benefit of our viewers and listeners, could you describe what exactly is industrial operations and what are the different types of plants and facilities that fall under industrial operations?
Sure. So, my professional journey towards this sort of product role is I started my education in industrial design, so that's like a physical product design development sort of focused area. So building stuff, figuring out how you're going to build it, how you're going to manufacture it, how you're going to produce it. And I did that for a little while, and then I went to trades and sort of was built actually physically building a lot of this sort of stuff, especially in the industrial sector. And then as my desire for problem solving and sort of investigative sort of poking around and stuff, I started to be asked more and more to solve problems or like to address product problems. And that drove me to sort of pursue additional sort of education in like ML or product or sort of software development, sort of augment my existing skill set. And it just happens that people ask me questions like, how do you solve this or how do you troubleshoot this? And that drove to the product space. And then I made a more conscious effort in the last several years to sort of uh, pursue and progress towards more of a product role, where I sort of found myself. And then to like, what is industrial operations? So it's a lot of like behind the scenes. So like how do you get water, power? Where does the gas from your car get into the gas station that you can fill up your tank with? Or, how do you make bread or groceries or apples and all that sort of stuff at scale and sort of move it along in this sort of process. So it's anything that sort of needs to be done at scale and at volume, right? So a lot of these things you can sort of think of industrial systems as like oil and gas operations. So how do you get the oil or gas out of the ground, and then how do you process it, because it's not going to be clean, or there's going to have to be some sort of like standard around it, and then how do you move it from where you found it to another place and do that all safely, and do that all 24 hours a day. And then you jump into things like data centers are another classic example of industrial operation. Like that's a giant server farm. So you have to deal with heating, you have to deal with cooling, you have to deal with power demands and draws, and then you have to deal with maintenance, and then you have to deal with, at a certain scale, this all becomes actually a really complex energy problem and a complex, HVAC problem. And then you have to tie all the data centers, like the actual like information in and out of that data center. And then how do you manage that? And how do those interact? And then, and then how do you plan to have that running 24 hours a day, but then also maintain stuff and then do updates? Like, your personal laptop, you'll get a ping saying like you need to update because there's a Windows update or a Mac OS update for your server or your operating system. So you have to do that for the thousands of devices in a data farm as well, like our data center. So you have to plan that and sort of execute on that. So that becomes like an industrial operational scale. Like how do you execute in sort of that continuous run? And then you get into things like airports, chemical plants, so things that um, produce plastics or cleaning sprays and things like that. Power plants, water systems, utilities, boilers, um, pulp and paper, mining, right? You're going to have to get all the stuff for your batteries at some way, somehow. Like, so you have to mine it, refine it, and then transport, smelt it down to actually like a metal that then goes into a manufacturing facility, which is another form of industrial operation, but more of like a batched operation, because you're producing one thing every so often versus like a continuous stream of product or process. Yeah, so that's industrial operations like impact our lives quite a bit. We don't typically see them. They're sort of like just off to the side quite often, but we definitely do benefit from a lot of industrial operations around us.
Thanks for sharing that, Carl. So it seems that there's a whole host of facilities that comes under industrial operations. Now, obviously, you work with many customers who are in the industrial operations space as part of Blue Marble AI. Would love to hear what sort of challenges and pain points that you're seeing in the industrial operations industry currently.
Yeah, so there's sort of two critical elements that I'll sort of level set. So a lot of these plants are really expensive and they cost a lot of money to build, right? So, the numbers of these things are usually like hundreds of millions of dollars to billions of dollars to build a new facility. So when you go and build these facilities, you typically want them to run for a pretty long duration of time, right? So, average time is, 40 years. There's some facilities that have been running in some form or another for like 80 years, maybe even 90 years in that sort of same location. They might not be using the same equipment, but the facility is still operating and sort of doing roughly the same thing. So um, technology is not the same, 5 years ago versus today versus 10 years ago versus 20 years ago, right? So you end up with this really interesting challenge of, you know, complexity increase. So something you built 20 years ago will be somewhat functionally fairly simple compared to something you would build today that would be functionally very complex. So a lot of industrial customers are dealing with this very interesting challenge of, at this point in time, this is the least complex their operations are ever going to be. So anything moving forward is going to become ever more increasingly complex. And it's really hard to predict what the complexity level is going to be like, 5 years down the road. It's like any sort of tech space, right? Like you can't predict what's going to happen next year versus 5 years, right? And a lot of these facilities operate in, multi-year sort of plans, right? So the complexity of the system they're trying to run is very hard to understand and very hard to sort of blend into some sort of business process. Yeah, so the pain point is that complexity, right? And there's something that we try to do at Blue Marvel, which is we try to create a mapping of how all these systems interact together with something that we call cross-product intelligence, where you can start to understand how all these disparate systems and their own right complex systems are starting to interact with each other and how they can impact and how you can build complex models or insights that can show how things are affecting different systems, or how you might be able to change or adjust something to improve the performance of a slightly associated or adjacent complex system in your operations.
Um,
Um,
Go ahead,
yeah.
sorry.
No, after you, I'll.
Thank you so much, Kyle. So thanks for sharing about the about the pain points and how Blue Marble is attending to those. Could you expand a bit more on the product portfolio of Blue Marble and the different categories? Would love to hear more, on how many applications is Blue Marble currently developing.
So we have, roughly about so we talk about our product suite as a suite of products. So there's sort of fundamentally probably about 5 sort of sub products, and they sort of land into sort of 3 main categories, and those are safety and risk, performance and reliability, and then energy and emissions. So those are the sort of 3 main silos that the products will sort of fit under, and those are driven by the data sets that are flowing into them, right? So safety and risk data sets are going to be very different than your performance and reliability data sets, and they will be different data sources. And this is where that suite idea comes into play with our products, and then how you can connect the dots between these sort of disparate data sets, and how safety will impact your performance and reliability will impact your safety and risk. And then all of that sort of filters up into sort of an ultimate sort of product, or ultimate sort of like application of energy and emissions, right? Because you can't do anything in an industrial plant without consuming some form of energy, and it costs you energy to do something more efficiently, or more because you're burning more to maybe produce less because you're being inefficient, or your reliability is not as great. So just sort of level setting in that, right now Blue Marble AI has about like 30 to 50 applications deployed across multiple clients and across multiple plants. So that number is a range, because it kind of depends on how you evaluate what an actual deployment is, right? So one of these sites, so an industrial site, might be one of 3 a client might have, and within that one site, you might have 3 or 4 applications working on that one site. Whereas, you might have you might have one application that's sort of universally being deployed across 5 different industrial facilities, but you're testing out one application at sort of their pilot plant to sort of confirm that the way their business operation works and their workflow works interacts well with that application, and then the outputs are valuable to that organization. So like it's a bit of a plus minus game, right? So like we have a lot of deployments, but we also sort of focus on plant specific deployments. But where our tool really is quite powerful is it's a sort of a universal sort of like enterprise based deployment. So when we deploy in the cloud for our infrastructure, we're actually not deploying at a site level. So you can be within the enterprise organization and look at information downstream of each of these individual plants, and start to sort of build a bit of a evaluative matrix around how plants are performing when you compare them against them. So you can sort of benchmark plants against each other, independent of decisions like control system and how old a plant is, or how new a plant is, right? So like it would be like comparing a fleet of vehicles, right? So you'd have like, a car that you bought in 1990, a car that you bought in the 2000s, a car that you bought in, 2010 and 20, and then one that you bought last year. And they're all going to be very different, and the performance might be different, and how they run would be different, but you can sort of benchmark them together as like, how efficiently do they get you from point A to point B, right? And how much do they cost you? And at some point, your car from 1990 might be costing you way more money than, a new vehicle, right? So it might make sense to either optimize or upgrade that particular car for your business operations, or you change what that vehicle is doing, right? So you might change what that plant is doing and sort of downgrade it or change the sort of outputs to meet what that vehicle might be optimized for, and then sort of off shift demands in your organization to other plants that might be able to be more optimized or increase capacity and sort of take up that slack.
Very, very interesting, Kyle. Thanks for sharing that. Now, out of all the products that have been deployed to your various customers, could you share some, success stories that your customers have experienced by using your product? And what are the KPIs that are being used to measure success?
Yeah, so we've had some really, really tremendous improvements when we've deployed applications to sites, because one of the challenges that a lot of these sites have is you have software that is sort of built within an island, and then it's very hard to filter that information up to people that are running the business, right? Like it's very easy for someone that's physically in the plant to sort of understand what's going on. It's very hard for someone at a business level or sort of an office level to understand the nuances of that information. So we're definitely helping bridge that gap, and allow that sort of to be seen in a sort of agnostic way. And then as soon as you get that in an agnostic way, you can start understanding why someone at the plant level is complaining about something, and you might be able to action it really quickly. So we've seen um, a couple deployments where we've had like very sort of like high frequency alerts or bypasses of safety risks associated, and there was just no visibility to the management level because they didn't have the access or the knowledge to sort of see what was actually happening. And as soon as they were able to see it, they could ask the question of like, why is that on, or why is that bypass in place, or why is this safety scenario happening? And they could ask the question and go through their own little work process and then alleviate the problem, right? So we've had some tremendous successes in that, where just simple communication, talking about the same thing, has enabled a drastic reduction in things like risk and safety at plants. This is also sort of translated into things like our energy application as well, right? So as soon as you start looking at sort of where your cost centers are, you might have something that costs you a lot of money, but proportionally you might be overspending on an asset that might be hidden by that really costly center, right? So, and you're trying to optimize that 0.1% on this thing that is costing $2 million a month, versus something that's $500,000, and you can optimize that by 10%, and all of a sudden you got $50,000 extra in savings without a lot of effort. So being able to sort of identify where your opportunities are and proportionally where to sort of spend your time has been pretty tremendous in a lot of our energy applications, and sort of monitoring and sort of visualizing that in sort of a very rules-based sort of statistical analysis and factual data piece there.
It's great,
Um,
great. Go ahead, sorry.
no, after you.
Yeah, it's great. It's great to hear all the success stories of your customers of using all your applications. So, many congratulations to you and your team for all the successes your clients have achieved after using your products. Now, Kyle, in terms of, the product development journey of Blue Marble AI, obviously AI is a big component of the product development process in Blue Marble. Given that the future of, product management would be AI product management, what sort of advice would you have for, for product managers who want to incorporate AI into their product? when should they use AI, when should they not use AI? What are some of the nuances that they need to be aware of? And would love to hear from your AI product development journey.
So AI is a very tricky topic, especially in the industrial space. It's a little bit clearer cut in the commercial space or sort of like a personal sort of application space because the there's more tolerance of risk and acceptance of safety on the personal and commercial side, whereas industrial plants, they are inherently super conservative and super risk adverse, right? So there's a lot of like you can't have false positives in your AI models, and there's scenarios where if you are optimizing or giving recommendations in a plant, you could blow something up. You could, brick $100 million steam turbine, or you could, kill someone potentially, right? So there's very, very high risk associated with sort of industrial operations. So your AI model needs to, as you build that, you need to understand that any sort of recommendations that are coming out of that for operations of that plant need to match up with that expectation that we cannot go over a certain risk threshold, or we cannot expose ourselves to damage of equipment or loss of personnel or risk to personnel, because a lot of these facilities also operate where there's really dangerous chemicals, right? So like H2S is a good example. So that's like sour gas, or like explosive stuff in a refinery, right? Like this is basically jet fuel, right? Like you're refining jet fuel, so that can explode, or even like fertilizer. That is basically one of the subcomponents of explosives, right? So understanding that and having that context, especially in the product space for industrial stuff in the AI application and sort of ML applications, is super critical. So that's the level set. Now, building AI models for industrial processes are really, really hard, right? And I'll use an analogy, and then I'll give some examples of how we've sort of tried to tackle addressing these problems with people. So predicting the wear of a tire on a car is an incredibly hard problem, but it's also very common to like an industrial process. So you have this thing that's running. You have a whole bunch of external factors that could be impacting the wear rate of that tire. And then it's going to be in a state of constant flux. So, a nice thing about having a car on a tire is you can stop and inspect it, and you can take it to a shop. An industrial plant doesn't stop, right? So they keep on running this tire 24 hours a day for potentially 5 years. So, and you can't get out of the car and look at the tire and inspect, is this bad or good? So you have to build out all this complexity, like, okay, so how fast is the tire wearing? Is this potential event going to impact my operations or not? Am I running the plant harder or underneath sort of my threshold for how fast this thing can wear? And all of these choices can be in flux, right? So you can sort of see an accelerated wear curve for a little bit in equipment or in the tire in this case, but then you might slow down for a while and then you sort of see almost no wear, right? Versus, oh, I'm going to take this thing off roading on a really sharp gravel road and I'm going to like start slicing up this tire, and it might not cause a puncture in the tire, but all of a sudden the integrity of your tire is potentially compromised. So when you maybe get back onto the highway and get up to like highway speeds, you're at really high risk of that thing potentially blowing out, right? And then causing a catastrophic failure. So you kind of need to figure out how to manage and build around this sort of very complex thing. And by the way, you might only have 3 or 4 training models to sort of show you what a failure might be in an industrial application, because a lot of these plants are sort of bespoke or sort of custom built. So you have some small elements that you can sort of train AI models on, but you kind of need to take all that with a grain of salt, because in the grander context of these sort of interlaying and complex systems, you might have some unintended or emergent behavior starting to sort of grow in these systems. So that all being said, that AI is hard in industrial. Um, how do we actually do it? So we do use AI in a lot in some of our products. We use ML in a lot in some of our products, but we use it sort of very sparingly and very targetedly. Um, and we try. And one of the things that a lot of people don't quite often know about AI is there's a lot of costs associated with deploying AI models. Like, they're very costly, right? And then there's maintenance, right? So it's one thing to build a model. It's another thing to have a model deployed and then maintain it over the duration of how long you're going to be using that model, right? So a scenario where a client came in, was asking for some support. They knew they wanted AI, they wanted image recognition. They'd already gone and bought all the hardware to like send high resolution data on this thing that we were going to like use image recognition to predict failures on. And what our data science base came back with is like, that might not actually be the solution for this. Like, you might actually, like, it's going to be really costly to sort of consume all these images at a resolution that's going to make sense. And even if you do catch something, we don't know if that's going to be soon enough to prevent the failure that you're trying to catch. So what we were recommending to this client is, you actually don't want to use image recognition first. You actually want to use pattern recognition and signal recognition, and sort of build a derivative model off of sensor data, which will be cheaper to deploy. And it might be just as good, and you might be able to get higher resolution information from that you might be able to catch faster than an image that's being taken like at 60 hertz versus a vibration sensor that might be at several hundred hertz, or 1,000 hertz, right? And that resolution can potentially be a very, very good value to sort of execute on that problem, right? And then this is also a classic problem in industrial systems and AI models, is the insight from the model, is that delivered in a timely fashion for you to action an item and actually see value in it. Because a lot of models are retroactive, right? So like, a lot of people will build models that look at historical data and be like, oh yeah, I could have predicted that in a day's worth of data or whatever. And whereas the time that they need to action that might be 5 minutes, right? Before there's going to be a dramatic impact to the operations team. So you need to like tighten up where the actionable insight comes to, and how that operations team can sort of execute against that, right? So you can build models on everything, and you might be able to predict it, but is the time window for when you can ingest the information, give some sort of insight or sort of actionable outcome, and then have operations or the industrial plant sort of adjust their operations to then catch the impact of that particular failure or that particular identified insight from the model, to then actually generate value from that, right? So, I'll go back to the tire scenario here, where, so if I build a model for, risk of tire flat, right? And I can, predict the tire is going to go flat in, 30 minutes from when the tire is going to go flat, right? So like, or when the event's going to happen, right? So if I'm going to have a failure on the highway, I might not have enough time to respond to that, so my tire might go flat on the highway. Whereas if I'm just sort of rolling around town, or maybe stopping and starting a whole bunch, I might have enough time and residents to sort of like, oh, I actually shouldn't drive the car down the street now because it's gone flat, and I know it's going to go flat. So if I tighten up my time for the highway driving, like, I need to know, 30 minutes before that's going to go flat, so I can like pull off the highway, slow down, get into a safe spot, versus like, oh, I'm going to have a flat in 20 seconds, figure it out, right? And then you need to like immediately stop on the brakes, potentially cause some damage, or put yourself at risk in the car in sort of the highway scenario. And get off the road really quickly because you want to try to save that. Or if it's only going to tell you in 5 seconds, like, yeah, you're going to have a flat in 5 seconds, and then bang, the flat, and they go, oh well, I'm in the middle of the highway. I guess I'm now driving on rims, and I need to now go into damage control. So in these industrial scenarios, like how fast you get the information to people and the right people in the chain can be very important. And then the models you present and how you present those models is really critical. Let me just take a look at my notes, make sure I've captured everything. Yeah, so another scenario where we've had a really successful AI deployment is we're looking at some like statistical and sort of like first principles model development on some leak detection, and we have gotten most of the way there, and we have some anomaly detection, and we've been successful in that, but it hasn't been 100%. So we now apply more contextual knowledge and some of that cross-product piece to enable us to sort of apply a dynamic model, which evolves from like an anomaly detection to a diagnostic model. And you start integrating some of the subject matter knowledge that we have on our data science team and amongst some of our partners, where you can sort of apply context to your pattern recognition. And then you start looking forward and labeling that failure mode, that failure curve, and then you start forward looking in that and sort of build in this sort of like dynamic model that starts to look at what are all these sort of external conditions that we also need to be aware of as to how fast we need to action this thing, because that becomes a critical bit of information for these models, is how fast do you need to action it, right? If you don't need to action it fast, then that's fine. But if you need to action it fast, you need to like surface that information really quickly and sort of have an outcome or an expected task to give to someone that so they can execute, right? Yeah, that's a couple like successful things and some challenges that we've had with deploying AI and ML models. Yeah, I'll just iterate. Models are great, but they do require maintenance, right? Like, you can't just plug and play and let them run forever, right? You have to like, there's an upkeep associated with a lot of models, because if the model's successful, what you've trained it on is no longer good data, right? So like you now need to retrain it on the new standard or the new baseline of how that plant is operating or what you're trying to detect in that system, right? And technology changes a lot of stuff, and changing business objectives will also change how these models in these plants will operate.
For sure. Thank you. Thank you so much, Kyle, for sharing such great insights on artificial intelligence, for giving specific examples and the analogy. I'm sure the product managers who are listening and watching to this show would derive a lot of value from what you just mentioned. So thank you for sharing your experiences with AI. Now, in terms of your organization, Blue Marvel's AI, future roadmap, where is the organization heading? Like, would love to hear its, 3-year strategy and roadmap. If you could share some insights on that.
Yeah, so we're in the process of evolving this concept that we have around cross-product intelligence and how you interconnect all these disparate data sets and have that based in reality and based in sort of factual information sort of feeding up. And then as soon as you have that interconnected play on your data set, you can start to do some very fascinating models and some very fascinating cross like AI predictions and KPIs. That's like our immediate sort of roadmap is this, like building the infrastructure to enable that. And then we have some really early stage models where we're in sort of partnerships with a few clients, where we're looking at sort of these interesting, interconnected, robust pattern recognition. So things like in an industrial plant, you're going to have a piece of equipment, and you're typically going to look at the performance of that piece of equipment. But the performance of that piece of equipment is actually a function of several items, right? So it's actually a function of how it's being operated, the condition of that asset, and then also the sort of stuff around that asset that is impacting that particular asset. So an asset might be fine, but it's performing poorly because stuff outside of that particular asset is impacting the performance of that asset. And building sort of tight models or sort of like statistical things only on that asset, you miss what you should be focusing on. So a lot of our roadmap right now is actually looking out a little bit and trying to connect the through line as to if there's a decision downstream or upstream of a particular asset, is that impacting that asset? And to what degree is that asset impacting? Or that decision or that action or that performance or that reliability is impacting that asset. And then from that, you can start to, if you have all this connected together and you know how much energy you consume or production that you're trying to build, you can start to equate a dollar figure or a production impact to these sub elements or these pieces of equipment. And a lot of like old timers or people that have worked in plants a long time will have a sixth sense for how something is behaving, but they've always had a very hard time articulating that to management or articulating that to the like business people that don't have any subject matter expertise in that space, so that they can say, well, it's not the problem with this particular pump, or it's not the problem with this particular asset. It's actually how we're using it. And they go, well, no, like it's the pump's the bad thing. It's rattling, it's making noise, just keep on replacing it, or doing maintenance on it. Whereas in reality, it's fine. It's how you're inputting into that pump or how the demands on the output of that particular pump that are causing this pump to prematurely wear or underperform and costing you more money, right? Or costing you more emissions, right? Or being just a mental mind sucked on the actual operations, because they're always having to go and bypass alarms or do sort of manual control on this pump because it's not behaving the way that we expect it to behave. So that's a huge focus for the next several years on us, is like building out that sort of fundamental infrastructure so we can have these relatively simple questions, but models based on reality of how things are actually connected, and then being able to translate the sort of ground truth to business truth and show that connecting line between, you're spending money on this, it's because of this. If you adjust this, and then because it's all ground truth, you'll be able to potentially see the delta or the change in cost, and then that's your business case.
Thanks, Carl, for sharing that. Lots going on with Blue Marble AI and exciting times ahead. So glad to hear that. Now, in terms of the future trends and market trends in the industrial operation space, where do you see the industry heading? Could you share some perspectives and insights on that?
Yeah. So like this is why we're focused on this interconnected stuff and doing simple things really, really well. And having that trust in the information from the devices all the way up to business management, right? And the actual business cases, right? So if you don't have that, you're basically asking people to trust you, right? And in an industrial application, trust is very hard, because a lot of these people will be held accountable, and it's a regulated environment if something goes wrong, right? You have an oil spill, you're going to hear about it on the news, right? So you can't have that, right? So you have to have that trust piece. So the trust component in AI and ML models is going to be paramount in going forward in the future. And the use of AI and ML models is it's going to have to happen in industrial operations, because the inherent complexity of these systems is only going to increase, right? So and humans don't scale as well as AI models or predictive maintenance systems will. So you're going to have to build out these systems within a lot of these companies, or sort of support within a lot of these companies, that will then scale easier as these things become more complex and interconnected, because it's only a matter of time for um, things like, emissions accounting or energy accounting that's going to have to be pervasive or be reported on, and they're going to want to be able to track how much energy goes into a particular asset, right? So you see this with steel production in sort of your heat numbers. So when you go and ask for a heat number for the mill, that gets stamped on that piece of steel, and that gets passed all the way through the manufacturing chain. So you have a custody control or a chain of custody from product to the steel in your car. I believe that's only going to become more and more important and possibly be adopted into a lot of these other industrial processes. So you're going to want to know, how that energy molecule moves through the systems across a plant, and account for that. Same with your plastics or chemicals or your paper. You're going to want to know how these things are being made or built, upstream and downstream of the individual plant operator, right? So someone might only make, lithium, ingots, or like lithium bicarbonate, but that's going to go into your batteries, right? And at some point, someone's going to want to know how much energy is going into that lithium for your battery, and then whether or not it's 50% recycled or not, and like where it's been sourced and how it's been sourced and how the offsets are happening with the emissions of that um, piece of asset, or that produced product.
Thank you. Thank you so much for sharing that, Kyle. So that concludes the formal interview of our, podcast show today. We like to end our interview with a fun segment called the Rapid Fire, where we, ask three fun questions to our guests so that our viewers and listeners can get to know a little bit about the personal side, of our guests. So are you ready?
I am ready. Fire away.
Great. Well, firstly, Kyle, as this is a tech podcast show, would love to hear what is your favorite software app or hardware product that you use on a regular basis that you enjoy using?
So I've been a proponent of Grammarly in like a lot of my writing. I have it on my personal laptops, personal equipment, and then my professional sort of business equipment. Uh, Predominantly because I need that support writing, like, and it's an excellent sort of lightweight AI tool that gives me some like adjustment prompts that I don't. It's not a heavy touch AI tool, and I've seen tremendous improvements in that tool as it sort of progressed. It's actually one of the tools I pay for. Um, so and it's been a great tool, right? So, and it allows me to sort of write a little bit more succinctly, and also sort of change my tone a little bit depending on how I'm writing, or what I'm writing for. But that's a great tool. I really enjoy it.
Glad to hear that, Kyle, that you're getting so much benefit from using Grammarly. Now, secondly, in terms of, what has been a book that you've read that has had a big impact on your life, and why?
So I a couple years ago I read a book called "This Is How You Lose the Time War" by Amal Motar, and uh, the book itself was such a fascinating premise around sort of two people that are basically enemies traveling like forward and backward through time, and all the cascading effects and sort of like nuanced complexity um, that comes across with that. And how would you conduct some sort of like, how would you fight someone across time? And yeah, it's a fascinating book. Great read. Highly recommend it for nerds. If it's not obvious, I'm a big fan of complexity theory. So and just generally complex systems. Um, but yeah, I love that sort of stimulation in my brain.
Thank you so much for the recommendation, Kyle. Now, lastly, is there any final words of wisdom, like perhaps a short story or a quote that you'd like to share with members of our audience?
So I have a couple quotes that I'll share. So one is Tesla's law, right? So this is a guy named Larry Tesler from Xerox in the 1980s. So if you don't know who this person is, you've used stuff that he's built. So he's sort of the person that built your copy paste command. So he's a big fan of sort of complexity. And so the quote goes as such. So total complexity of a system is a constant. If you make a user's interaction with the system simpler, the complexity behind the scenes increase. So this sort of statement to me really means like complexity is like you can't destroy it or get rid of it. You can just sort of shift it around, right? And in the product space, that's really important to understand. So if you are creating a simpler user interface, you're going to make the backend a lot more complex, or you're going to have to understand the problem a lot more prior to the user interacting with it. But if you make the user interface way more complex, or the way someone interacts with something more complex, it's going to be simpler to code because you're just going to offload all that cognitive load onto the user. So there's an interesting balance that needs to be played, and I think it's even becoming more of a critical thought process in product as you sort of deal with AI and ML. It's like, what complexity are you offloading to an ML model or an AI model, and then what is the output of that? And is it going to be just a simple yes or no, or is it going to be a more complex output? And how does that all interplay is really important to understand, because you can't get rid of complexity. You can just sort of shift it around and try to address it. Which like obviously I have a little bit of design background. So Don Norman, he's an author of Design of Everyday Things. He has a great quote, which is like, complexity is not bad. It's confusion that's bad. Forget about simplicity, and like, long live well managed complexity, right? So that sort of plays into my other quote there of like really trying to understand the complexity, which in itself is trying to address the problem, right? What is your problem statement? What are you actually trying to solve? And that should drive you to understanding the nuances and complexity of the systems that you're engaging with.
Great, Kyle. Well, thank you for sharing that, and thank you so much for your participation in the rapid fire round. Now, should our viewers and listeners want to get in touch with you, what's the best mechanism?
So you can connect with me on LinkedIn. It's Kyle FALOON, so KYLEFALOON. Look me up, or by email, same name at bluemarvel.ai. So kyle.falloon@bluemarvel.ai. Feel free to reach out, and if you have some questions, happy to have chats.
Well, great, Kyle. So thank you so much, for joining our show today. It was an absolute honor and pleasure having you on our show, and for sharing your subject matter expertise on industrial operations and AI, and more about your product development journey. Really appreciate you having you on the show here. So from the team at Energize, wishing you and the entire team of Blue Marvel AI all the best, lots of success and growth.
Thank you very much.
Yeah.
Hope the revolution continues on for you guys at Energize.
Absolutely. Thank you for that, Kyle. So there you have it, ladies and gentlemen, our episode for today. And remember, you're one product away from transformation. I'm Arjun Chaudhary.